The description of electrons inside atoms tells us a lot about chemical properties. It's the electrons that meet each other when atoms touch atoms. And atoms touch atoms is electrons pushing against electrons or electrons interacting with electrons that create our chemical bonds, our chemical properties. We have a series of 4 quantum numbers that describe the energy levels or properties of the electrons inside the atom, and we use these 4 quantum numbers to describe the properties of our electrons. Those 4 quantum numbers are n, which is the principal energy level, and n is a counting number, starts at 1, goes up to infinity. L, which describes our sublevels, and L goes from 0 up to n minus 1. Then M sub L describes our orbitals, and it goes from negative L to L. Then M sub S is electron spin, and we only have 2 choices, plus 1/2 or minus 1/2. So for n equals 1, the principal energy level, first principal energy level, what's the maximum number of electrons? There are 2 ways to answer this or view this. Maximum number of electrons is 2n squared. We put 1 in here, and that, of course, is equal to 2. So maximum number of electrons is 2. The other way is that n equals 1 means we only have 1 sublevel, S, and S holds 2 electrons. So we have 2 electrons, whether we use 2n squared or look at the number of sublevels that are available. If we are given a set of quantum numbers, we want to describe where the electron is. So n equals 3 means that we are principal energy level 3. L equals 0 is sublevel. 0 is the first sublevel, which is S. So we are dealing with the electron in the 3s level. ML equals 0 is not telling us anything additional because S only has 1 orbital. So it's in that 1 orbital. And MS 1/2, we could take by convention that positive 1/2 would be a spin up, negative 1/2 would be a spin down. So this would be a 3s electron in spin down configuration. For 8a, we want to describe the quantum numbers for the last or highest electron in aluminum. Well, aluminum is in period 3, so that would be n equals 3. Well, specifically it's in P, 3p. So that means n equals 3, and then for P is our second sublevel. Second sublevel is going to be n equals 1. It starts at 0, so 0, 1, so L equals 1. And this is truly the only 2 numbers that we have for certain. M sub L could be a negative 1, a 0, or a 1. That would be the 3 orientations of the orbital, the p orbital. And then M sub S, the spin, could be either the positive 1/2 or negative 1/2. And then M sub L, what does that describe? Well, up here it's saying the orbital. Well, there are 3 orbitals for P, And those three orbitals are just orientated differently in space. So M sub L is our orientation of the orbital in space.